Hey folks, and welcome back to our second video here in Unit 10. Here we're going to be introducing oxidation numbers. This is going to build on our video from talking about ions from yesterday, so make sure that you go back and look at that first if you haven't done this yet. Otherwise, not quite everything will make sense. So, important piece of information that you need to know in order for all this to make sense. Atoms want to be stable like the noble gases, okay? The noble gases, if you'll recall from our last unit on the periodic table, are extremely unreactive. They do not react with anything, and that's because they're very stable. They're calm. They don't need anything else. They're very good as themselves. We've already seen atoms trying to become stable when we were talking about nuclear radiation. We talked about that there are radioactive elements that are unstable, and in order to become stable, they have to modify their nucleus. They have to change the number of protons and neutrons that are in the nucleus. This is a different kind of stability, but it is very similar, okay? And the way that elements become stable, or atoms become stable, is to have electrons that are similar to the way that the noble gases have their electrons. And what that means is that they need to have their outer energy level be full. Okay, so they want their outer energy level to be full of electrons. Now, let's remember how many electrons need to be in each energy level. So the first energy level has 2 electrons. So as soon as that has 2, that's full, that is stable, okay? And remember when we were talking about the Bohr models, how you put 2 electrons in the first level and then you went to the next level? Again, that's because each of the levels wants to be full. So now the second energy level, that needs to have 8 electrons. Okay, so you would put 8 electrons in that second energy level, then that becomes full. And then the third energy level also wants to have 8 electrons, and it keeps going up from there. So if we take a look down here, right, these are the noble gases, or some of the noble gases. You have helium, neon, argon, and krypton. Helium, that first energy level, has 2 electrons. That's full, so therefore that is stable. Neon has 8 in its second level, so therefore it's stable. Argon, 8 in the third level, it's stable. Krypton, 8 in the fourth level, it's stable, so on and so forth. Okay, so that is the basis of this, of the way that chemical reactions take place. Okay, chemical reactions occur because elements or atoms want to become stable, and what they're going to do in order to become stable is they're going to be gaining or losing electrons. So the way that atoms fill their outer energy levels is to either get rid of electrons or they're going to be gaining. And elements are like people. They can be lazy, right? And so what they want to do is they want to do the easiest thing in order to get their outer energy level to be full. So let's take a look at a couple examples. Let's take a look at magnesium here. Magnesium has 12 electrons, so it's got 2 in the first level, 8 in the second level, and then 2 in the outermost level. All right, so it wants to have 8 in the outermost level. Now, there's 2 options here. It can either gain electrons or it can lose electrons. If it were to gain electrons, it would need to gain 6 electrons in that outermost energy level in order to get to 8, right? Well, the other option is to lose these 2 on the outside. And if I lose these 2 on the outside, that means that now there's going to be 8 in the outermost energy level. It doesn't matter that you've gone from having 3 energy levels to 2 energy levels. All that matters is that the outermost energy level is full. So what's easier? Is it easier to gain 6 or is to lose 2? It's much easier to lose 2, right? So magnesium is going to kick out those 2 electrons. Now it has 8 electrons in the outermost energy level. And relating back to what we were talking about on ions in our last video, now it only has 10 electrons. But the number of protons that is in the nucleus has not changed. And so therefore it is going to be magnesium with a +2 charge, because you have 2 more protons than you have electrons. All right. So that's our magnesium example. Let's move over. Let's take a look at oxygen. Oxygen has 8 protons and 8 electrons. So it's got 2 electrons in the first level. It's got 6 in the second level. All right. Now it wants to get to 8 in that outer level. 2 options. It could either lose these 6 and then go down to the first energy level, which would have 2 and be full, or it could gain 2 electrons. So it's much easier to gain 2 electrons than it is to lose 6. So it's going to add on 2 electrons. When we do that, now we have 8 in the outermost energy level, and we now have 10 electrons in our new oxygen. Because we now have 10 electrons, our number of protons did not change, meaning that we now have oxygen -2, or oxygen with a -2 charge. Okay, so that's how that relates back to ions. Let's take a look at a couple more examples using my whiteboard. Okay, so let's take a look at lithium. Okay, lithium, when we look at the periodic table, right, it has an atomic number of 3, so that means that it has 3 protons. So it's going to have 3 protons in the nucleus. I'm not going to worry about the neutrons right now. And in a neutral element, it's going to have 3 electrons. So 2 in the first energy level, 1 in the outer level. All right. What's going to be the easiest thing for it to do here? Is it going to be easier for it to gain 7 electrons, or is it going to be easier for it to lose this 1 electron here? Much easier to lose the 1, so that's going to be gone. And what this is going to turn into is our lithium here with just 2 electrons. Now, we've got 3 protons. Now, let's move this down here. 3 protons, 2 electrons. What's going to be the charge on our lithium? Well, we've got 1 more proton than electron, so this is lithium with a +1 charge. Now notice, right, we're only dealing with electrons that are in the outermost energy level here. What's our vocab word for those? That's right, it's our valence electrons, okay? So atoms are only going to gain or lose valence electrons in order to try to get that outermost energy level full. Again, in this case, it's okay that it's only 2 electrons because the first energy level can only fit 2 electrons. So this is still considered to be full. Okay, let's look at one more example. Let's take a look at nitrogen. All right, looking on our periodic table, nitrogen has 7 protons. First energy level, same thing, 2 electrons. Second energy level, 1, 2, 3, 4, 5. Okay, so we have 5 electrons in the second energy level. Is it going to be easier to lose those 5 or gain 3 so that we can get 8? Obviously, it's going to be much easier to gain 3, all right? So we're going to end up with 7 protons still in the nucleus, 2 in the first energy level, and then 8 electrons, 6, 7, 8 in our second energy level, okay? So now we have 7 protons. We now have a total of 10 electrons, okay? Which means that our nitrogen is now going to have a -3 charge. And again, this is because of the number of valence electrons that needed to be added on. All right. Now, if you will recall, if we look at our period, or if you remember from the last unit, what is the trend with valence electrons? Well, the number of valence electrons, right, increases across the periodic table. And that means that there's going to be a pattern to the oxidation numbers, okay? Because all of the group 1A elements have 1 valence electron, lithium was an example we just looked at, all of the elements in group 1A will all lose that 1 valence electron in order to fill their outer energy levels, and so they will all have a +1 charge. They're all going to lose 1 electron. Magnesium, right, has 2 valence electrons. It's always going to lose those 2 valence electrons. So all of group 2A is going to have a +2 charge. Okay. The transition metals, we can't tell because the rules for valence electrons there are weird, so we can't look at the periodic table. But if we skip over to group 3A, it's +3, right? Group 4A, plus or minus 4, right? It's equally easy to gain 4 or lose 4. And then we have group 5A, that was our nitrogen, right? 5 valence electrons, easier to gain 3 electrons and become a -3 charge. Oxygen we just took a look at, gained 2 electrons. It has 6 valence electrons, so they're all going to gain 2 electrons, be -1. And then -2, and then -1 for the halogens, and then finally for the noble gases. Remember, they don't do anything. They're already full, so they don't have oxidation numbers, okay? Okay, so if we take a look here, our metals, they tend to lose electrons, right? Because they only have a few in that outer energy level. They only have a few valence electrons, so they tend to lose those, right? Whereas our non-metals, they are going to tend to gain electrons because they have a lot already. They just want to pick up a few more in order to have their outer energy levels full. All right, make sure that you do all the practices for this because it's going to be very important once we start getting into talking about chemical bonds and how do elements actually combine together to form compounds. All right, thanks for watching, and I'll see y'all next time.